Okay, semiconductor diode. So last meeting, we've learned this is the electronic symbol for the diode, right? So kung asa ning line, muna siya ang negative na terminal. So kung maning negative, of course, because ng positive terminal. We've also learned that the main purpose of the diode is to act as a switch. Okay, to act as a switch. Yeah, basically, mo lagi diyahang kuan, no? Main nga use. Ang other uses niya is mo stem sa kana nga function. Function siya switch. Because switch siya, wala kayo yana ka how should I put it? Wala kayo something interesting, no? If we are only going to measure the voltages and currents. So somehow, one way para ma-visualize gid nato ang use of diode is for us to hook up our circuit to an oscilloscope or to the oscilloscope, which measures or shows us, no, display to us the image of the output and the input and output waveforms. So sa yan nga aspect, we not only measure the voltages and currents of the circuit of which the diode is in it, but also the wave shaping capabilities of the diodes. Okay. Wave shaping capabilities. Okay, wave shaping capabilities. And sometimes we also use the diode for circuit for protection, circuit protection, or load protection. So i-parallel kibaling diode sa isa ka device or load na very sensitive. Okay. But because the diode is a very complex device, no, technically speaking, complex yung device, it would be difficult for us to use the Shockley equation to measure to calculate for the actual current. Okay, it's not a linear device, unlike the resistor that we could use just Ohm's law to make our analysis. So we need to employ various models, diode models or diode equivalent circuits. So we have three. We have three ways, to model our diode. One is the diode as an ideal device. Okay, because the diode is a switch, we could think of it as a switch. So ang iyahang graph kay bali, the diode as an ideal device. If mo na iyahang VI curve or current voltage current curve is ingane. Okay. So when the diode is off, it may be nasa zero nga voltage or negative. So zero current. If ever nasa current, zero ang voltage. That's how switches operate. Another diode model is the simplified model. Simplified. Simplified model. So not only the diode is a switch, but it also acts as a potential or mara siya voltage source, ibali, no, na siya a battery. So if sa ideal device, ang diode, naman siya duha ka state, on or off. When it is on, so closed switch. When it is off, open switch. So simplified model, not only is it a switch, but also a battery. So iyahang VI curve would look somehow like this. At ay what we call diode voltage, VD. So yan na iyang characteristic curve. So when the diode conducts, it only conducts at this value, VD. So when it is off, the same gapon sa previous, no? When it is off, no current. So open circuit. But when it is on, not only is it a short circuit, but it also has a voltage drop, no? VD. Diode voltage, VD. So how much again is the diode voltage for silicon? But memorize na nga constant. Pila ganito?
0.7.
Okay, thank you, Nico. 0.7 volts for silicon. And for germanium, it's 0.3. There's also another model more realistic than any of these, but model still because really good siya kato actual, no, na kuan. Hindi siya actual na behavior sa diode. The diode as a piecewise linear model. So somehow more siya resistor. No? Piecewise linear model. Okay. So yung difference, siguro kung compare nato sa simplified model, yung graph is if mag-conduct siya, so the same gapon, nagyapoy VD, if mag-conduct siya, it act as a resistor. So ang VI curve sa resistor kay ingani man, laos na dito. So yan ang resistor, but because this is the diode, it will only conduct in one direction, and once it conducts, it acts as a somehow sort of mag-resistor. So in the on state, short circuit, voltage drop, and ay gamay nga resistance. We call that one RAV, or average voltage, average resistance sa diode. And kung off, the same gapon. Open circuit. Now, which of these ang atong i-use? Okay? We're going to mostly use a simplified model. Not only is it more realistic than the ideal device, kaya dili man gyud technically switch lang ang characteristics atong diode, but it also has a voltage drop, no? Mas realistic ang simplified. Now, how about this one, kay mas realistic pa man ang piecewise kaysa sa simplified. Kung piecewise man god na aning resistor, no, may madungag lang siya gamit sa atong analysis. So if ever, no, if ever the total resistance of our circuit is very much larger than this one, So, ang value sa average resistance of our diode, of our device, is naraman siya sa mga few ohms, no? Less than 10 ohms. And if our circuit employs few ohms na siya, and if our circuit employs resistances in the range of kilo ohms, no? Kilo ohms, pwede lang na ito i-disregard ang average resistance sa diode. Or we could use the simplified model. So again, for the most parts of our analysis of diode circuits, we'll use a simplified model. Maybe we'll use the ideal model or ideal device when we deal with wave shaping capabilities of our diode. Para mas ma-simplify pa rin further. Gamay ra ang changes na mahatag sa addition of the voltage drop when we speak of the output waveform of our diodes. So, pwede na ito magamit ng ideal when dito na ito sa mga wave shaping capabilities, no? sa itong diode. Okay, so, example, para at least madumduman ninyo nga when we'll use the ideal diode kung wave shaping capabilities na. So what kind of wave shaping capabilities are there when we use the diode as a rectifier, as a clipper, as a clamper? Kanang mga uses, mas mo focus ta sa output waveforms of our circuit more than the voltage levels or current values. Okay. So for the remainder of today's meeting, focus lang ta sa normal silicon diode or the junction diode. Sa sunod na siguro ang Zener diode. So let's try to analyze a very simple circuit. Example. We have a voltage source. In series sa iya ang diode. And this is the load. Of course, na ground. Let our source be 10 volts DC. Our diode silicon. And our resistor 500 ohms. Question. Required. Find diode voltage VD, diode current ID, and resistance voltage VR. Required, solution. Now, before anything else, especially when dealing with diode circuits or electronic circuits, ang general rule yun the first rule is to know what is the condition of our device. No? Especially this one. What's the condition of that one? When I say condition, and if tungkol kay diode naman sad na, doon naman yung condition, either it's on or off. No? So before solving for any of these parameters, ato sa i-determine at what bias our diode is at. Okay? Bias. This is a technical term. In the study of electronics, it means something else compared to how we normally use the word bias. No? So outside ECE, what's the meaning aning a word? Bias. How do we normally use this word? Malasiyag somehow, sa ba? May preference, okay, good, no? May preference or unfair, di ba? Unfairness, bias. So that's how we use bias outside the study of electronics. But sa ECE, electronic circuits, when we say bias, or if an electronic device is properly biased, that means that device is turned on. No? So when we say we want to bias our electronic device, it just means that we want to turn it on. So biasing is the turning on, no, of our device. So in this case, the diode. So matong first i-determine unsa iyang bias right now. For the diode, we have two biases, the forward bias and the reverse bias. So for the diode, forward bias and reverse bias. Remember these terms. Ma-apply gapon ni siya sa transistors soon. Forward bias and reverse. Napoy no bias, di ba? When you say no bias, kana lang ng diode nga naka-standby somewhere. Wala siya gigamit. Okay. So, sa manibing. For the diode, we have, I think I mentioned ganyan ako ni last time. But, para review, for the diode, for it to be turned on, or for it to be in a forward bias mode, these two conditions must be met. First condition, if kanya silicon man siya, the voltage drop of the device, voltage drop of the diode, okay, should be greater than paklaro ang tingog, ulan na ba dire? Okay na ba?
Yes, sir. Yes, sir.
Okay na, sige, thank you. It should be greater than 0.7 volts kung silicon. Kung germanium, greater than 0.3. So in this case, kaniyatong example, 10 volts, layo ba, no? So di na kahit mag-worry aning number 1. Kung 1 volt ni siya, example, kana 1 volt, mas dako pa man siya, di ba? 1 volt is greater than 0.7. So somehow di kayo mag-worry sad. Unless 0.8 siguro ni or 0.7, no? Diha medyo mag-doubt na ta if masatisfy ang first condition. If the voltage source of the whole circuit is greater than 0.7, especially this one, di na kayo mag-worry sa first condition. Second condition, the direction of the current, so kapag-state ba? The current flow, ibali, Flow of current should be the same. To direction of diode. The flow of the current should be the same to the direction of the diode. Because we know that the diode passes current in only one direction. Ano ha? Asa padlong ang arrows sa atong silicon diode? Padudto, di ba? Padudto. Unang direction sa atong diode, the device itself. Now, ang question, unsang direction sa current sa circuit? No? Pwede man ito mag-assume. And sometimes we may assume wrongly. And okay ra, kay if ever bitaw wrong atong assumption, don't worry because mugawas na siya sa atong solution. No? Later, ako ipakita ang mga examples sa mga possible na wrong assumptions. Mugawas na siya sa atong solution nga. Uy, sayop na akong assumption. But in this case, I think dili ra kaayo dako ang assumption or dako nga matter if ang ato assumption is ang flow sa current is the same sa flow sa diode nga direction sa diode, no? Ani ha, voltage source man di ba? Voltage source. Basta sources, kon lang ni siya malag mental note na lang. Basta sources, maybe lahi ang convention sa circuits ninyo nga subject. Okay na siya. Convention lang man no? Malag rule of thumb lang. Basta sources, current always flows from negative to positive. Whereas for devices or loads, current always flow from positive to negative. So, klaro man nga ang atong source is na ay polarity. Okay? Basta battery naman ginay polarity, plus minus. How about ang resistor? Wala siya polarity. We know po nga atong silicon diode polarized na siya. So, na siya polarity daan. So, asa yung negative? Kung asa ni nga linya, di ba? Kung asa na nga linya, sa iyahang arrow, diha ang negative na terminal. So, napod ay ang positive. As you've noticed, mo-hold true ni nga rule or ang convention. Mag-flow ang current from positive to negative. From positive to negative. How about the resistor? Okay? Kung sa iyang polarity, by itself, ang resistor, wala gina siya polarity. So, pwede ito mag-assign of yung polarity. Because ground is here, adli ang ground, meaning this wire is ground, meaning ang atong resistor is connected to the ground through this terminal, meaning that terminal is negative. Meaning the other one is positive. So, as ang current flow sa circuit, it should follow because sources, asa mo gawas ang current sa source, positive. So, dili mo gawas. Dili mo originate kaninga terminal ang current ni battery. So, I think it's not wrong to assume na mo ni iyahang current flow. Kana. Okay? So, if muna ang current flow sa circuit, the same ba siya sa direction sa current flow sa atong diode? Yes or no?
Yes, sir.
Yes.
Okay. Yes, that's correct. So, atong circuit mo, yung direction. And ang atong diode, direction sa atong diode pa dito. So, nisabay na siya, no, ni uyon sa kibali. Nisabay ang diode sa direction sa circuit. And di man po siya, medyo obvious man po siya sa kaning example kasi mo pa man yung pinakasimple nga example sa tanan. So, as for this circuit, so, na-satisfy ang first condition, yes, voltage nga criteria. Satisfy po ang current nga criteria. So, pwede na ta mag-proceed sa solution nga, numerical solution nga part. Solution. Kung maanad na tanaw sa itong mga circuit, no? Daghan na kayo solve nga diode circuits, pwede nga sa isa pa lang katanaw, kabulon na dayon ta kung sa state sa diode, kabulon na dayon ta nga on ba siya or off. Okay? So, kani, obvious man noon nga, on si diode. So, if on siya, and we'll be using the simplified model, pwede na to i-replace si diode as ingani. No? Then 0.7 nga voltage drop. So, pwede ito magbuhat-buhat ug atong own nga analogy nga circuit. Nga na. Okay. So, sa mga requirement, BD, ID, o BR. What is BD? No need to solve. BD is equal to 0.7 volts. How about ID? Now, we can't use Shockley equation. So, man kayo ito gamiton. Dagan kayo parameters nga dili given. Kung sa nga klase nga circuit ni, duwala man ka klase nga simple circuits, and this is a simple one. Start sa letter S.
Series.
Okay, series. And when we know it's series, kung saan equal sa tanan components, basta series.
0.
Ang current, di ba? Current is equal in all components. I total is equal to I1, is equal to I2, so on and so forth. Right? Meaning, the current that is flowing sa atong silicon would be equal to the current that is flowing sa resistor, which is also equal to the current nga ginaproduce sa atong voltage source. We can't know directly what is the value of the current sa atong diode, but we can solve for the current of the resistor. We can solve for the current of the resistor, but not directly, kay wala kumantay voltage drop ni resistor. Using Kirchhoff's current law, how much do you think is the voltage drop ni resistor?
9.3, sir.
Okay, 9.3. No? It will logically follow. No? Mag-loops ako, okay? Loop. Kirchhoff's current law. Loop in that direction. According to KCL, the summation of voltages sa isa ka loop will always be equal to 0. Okay? Meaning, if we add all this together, add na ito nga mga voltages, equal to 0. Meaning, voltage source plus voltage sa diode plus voltage sa resistor. Dapat mo equal 0. But, kung mag-loop ko dire, okay, from this point, tuyo ko, padlong dito, no? Mo ni atong KCL equation, but wala pa nato gi-assign ng sign, no? How will we assign signs sa atong equation? Simple lang. Kung asa mo gawas ang current, mo to ang sign sa atong device. Example, dire, no? Sa battery. Amo ta mo sugod, gikan dire. Padalong didto. Usay sign sa iyang exit,
Positive, sir.
positive. So, positive ang sign ni voltage source. Abot kay diode, sulod sa positive, nagawa sa negative. That's why dapat negative na siya. And the same sa resistor, sulod sa positive, nag-exit siya sa negative. Negative. So it will follow that Vs minus Vd minus Vr is equal to 0. Vs is 10, Vd is 0.7, minus Vr, which is unknown. Therefore, Vr is, yes, correct. Itong answer earlier, 9.3 volts. So, check na ni. ID na lang. The current sa diode. Okay. ID. But because this is a series circuit, ID is also equal to IR. Current sa resistor. And how will we determine the current sa resistor? Ohm's law. Na naman tayo na may constant value ng resistance. Na tayo value sa voltage. So, current na lang using Ohm's law. Using Ohm's law, I is equal to V over R. Right? So, VR is 9.3. Resistance is 500. So the current resistance, the resistor current is equal to 0.0186 amperes. But kung sa electronics gani, it's a common place to put it in a milliampere nga notation. So this is 18.6 milliamperes, which is also the diode current. Any questions so far?
None, sir.
Sabtan na ni?
Yes, sir.
Okay. Sige, let's look for another example. So if you have your textbooks with you, hard copy or soft copy, adto mo sa problems na part sa kuan. Sa chapter 2. Okay, chapter 2 naman dahil sad ni. Dili problem number 4. The same na ganina. The same type of circuit. 30 volts. Kani silicon daw ni siya. And resistor nga 2.2 kilo ohms. So atong paspason og solve. Voltage sa resistor is just equal to 30 minus 0.7. 29.3. 28? 29.3. Okay. Current sa resistor. 2.2, no, 29.3 divided by 2.2K. 2.2 kilo. Or meaning 2.2 times 10 to the power of 3. Kung ng kilo, di ba? Kilo ohms. So 29.3, 2.2 kilo. $13.32 milliamperes. Para straightforward na ba nga solution, no? How about this one? Do we need to solve this one? So, sa itong first na determine ang state sa diode or ang iyang bias, kung na properly biased ba si diode or not. In terms sa value sa atong voltage source, enough ra ba ang 12 volts supposedly to power up our diode? Yes, di ba? 12 volts. But, naibat,
Dili ka correlate ang direction, sir.
yeah, very good. Thank you. So, ang direction sa current, ang assumption is mag-flow mo ng current na to from sa source, mag-gawas mo siya sa positive. So, muna yung direction sa itong current. No? So, mabangga siya sa current sa diode, current direction sa diode. So, ang approximation ani, or before we go any further, ang yung equivalent circuit, I mean,
Off.
off. Right, thank you. Uh, 100 ohms. So, at this point, we could conclude that current is equal to 0 amperes. Because current is equal to 0 amperes, this is the current of the whole circuit. This could also be the current of our resistor, meaning the voltage of our resistor is also 0. Okay? V equals to I times R. I is 0, R is 10, 0 times 100, 0 times 100 is 0 voltage. Now, how much is VD? Would like to guess.
0.7 gyapon, sir.
0.7. Mhm.
12.
0, sir, kay open circuit man.
Open circuit. Okay. So natay mga guesses. Napay another guess? Try to think. How
12 volts, sir.
would
12 volts.
Kirchhoff's current law remain in force? No? If magkuanta kay nabi dili ang VD, dili na to gi-measure. No? Diha. So for KCL to remain in force, dapat the total voltage sa whole circuit, the total voltage of the circuit is equal to 0. No? So kung 0 ang iyang voltage ni resistor, 0 volts na siya. For KCL to remain true, if 12 volts ang source, ilang VD? Dapat VD is also equal, dili 12, negative 12.
Negative
Basta mo
12.
mag-measure. Kung mag-measure ta nga dili ang positive, dili ang ground, negative 12 volts. Negative 12 volts. So correct inyong mga magnitude, pero negative siya. Para kung i-total lang silang duha, 0. Okay. Just try to imagine another one. If ever dili na to need i-invoke si KCL, naatay multimeter here. Okay, multimeter. Gusto na to i-measure ang iyahang voltage drop. If open circuit si diode, kay kinsa nga voltage drop ang ma-measure ni multimeter nga 12 volts. Dili ba na i-direct nga connection gikan diri padulong sa battery? Voltage drop sa battery iyang directly nga ma-measure, no? That's why the voltage drop sa diode, even though open circuit siya, is negative 12 volts. So that's 5A. 5B. Let's say kana 20 ohms, 10 ohms, silicon gyapon ni siya. Or we could also withdraw it, no? Withdraw na to ang sa form nga marag naanad ta. Yan na. Okay. First question. What's the state of our diode? On or off?
On, sir.
on. So naman di atong originally naman di atong ground. Adire. So na diri si ground. Yeah. Sige, let's assume nga on siya. No? Kasi this is R1 and this is R2. So resistance 1, resistance 2. Or resistor 1, resistor 2. First na to nga tuyok KVL dire mo kuan lang no mo sabay lang ang direction ni kuan mo sabay ang direction ni battery sa atong diode. So 20 minus VR minus 0.7 is equal to 0. VR is equal to 19.3. So because VR is 19.3, IR is equal to 19.3 divided by 20 ohms. Magdani sa mga ampere nga range pa. 0.965 amperes. Okay, mag-make sense pa itong answer. So, I think it's correct. Ang atong assumption is on siya. No? May isa ka-trivial nga circuit dire. But, it's best na ma-encounter lagi hapon doon. When a circuit looks like this, what do you think? Sa iyong opinion niya, ano eh? Si Diode 1, panaog. Yeah, si Diode sa silong, pataas. Current is 0. Sa kanilang sad nga branch, no? Kani nga leg sa tunga. Yes. So mahulog na for DC circuits, no? For DC, for direct current circuits, because dili na ni siya mag-work nga reasoning kung alternating current. But for direct current circuits, basta ingani gani itsura sa atong diode, as good as wala na siya ga-exist, no? So pa may pulos lugar ani, di man siya pwede mo flow sa Pica's direction. Mo conduct ang isa, pero ang isa open. So basically, kaninga leg exist. So for this leg alone, yes, current is equal to 0. Therefore, ang current sa atong resistor, just try to imagine, wala siya. So malag ang ga-exist lang kibaling circuit is only this one. Kana lang circuit ang ga-exist. Kana nga part sa circuit. So non-existent ang suto nga. Easily solvable ang current ni resistor. Current is equal to 10 divided by 10. 1 ampere. Last one before we end. Number 6. Kani, this is a common notation used in electronic circuits. So this is the first time, I believe, na ma-expose mo aning notation. So better na ma-familiarize na ta ani daan ron kaysa sa sunod pa na to ma-encounter. So again, this is a very common na notation sa pag-draw of electronic circuits. The circuit ba ni nga manig mga lines, no? Ang complete circuit nga akong nailan before is katong na-complete yun nga loop. Okay, but again, kasagara sa pag-draw na tog circuits in the future, especially when dealing with transistors, is ingani, no? Ingani nga notation. So how do we redraw this? Before solving, no, how do we redraw this? Actually, mas convenient gani kung mag-KCL ta. No? But how do we redraw this one? Para mara siya the usual circuit nga naanad ta, no? Katong box type. Ang bago siguro sa ato is this one. Kaning notation so pag-draw sa source. Kani o kana, no? So what do we do? So these are what we call nodes, no? Technically node magyapon ni But let's just name this one's node. Okay. Node ni siya, node pud to. So when we say node, most definitely na naka-connect ana nga element diha. And basta mga elements gani, 2 terminal gina siya, di ba? 2 or more. So tungod kay battery ni siya, duha gina yang terminal. So iyang positive na terminal, meaning na positive 8 na battery na connect sa kaninga node, yung positive terminal kay bali is connected dire. So asa connected ang isa, basta node gani, ang other terminal is connected directly to the ground. The same with this one. Meaning ang positive na terminal ni voltmeter VO is connected here, ang negative is directly connected sa ground, no? So dala si ground nato. So ato nang i-redraw, no? I-redraw nato. Meaning connected dire ang positive terminal sa 8 volts nga battery. Okay. So connected diha ang positive terminal sa 8 volts nga battery. Asa connected ang negative na terminal? Directly sa ground. So naman dito atong ground. Connected directly to ground. The same gyapon ani VO. So natay meter dire, multimeter. Natay simbolan na gyud. Lang butang nga dire VO. Siya measuring tool kay bali nato. Yung positive terminal connected dire. Yung negative terminal connected directly sa ground. Eight volts, 1.2 kilo ohms, 4.7 kilo ohms. So the same gapon ganina, KCL ta. Kirchhoff's current law to dire. Ano, KVL din, no? KVL din dapat ang term. KVL to dire. So 8 minus current ni R1 1.2K minus current ni R2 minus 0.7. Now, 0 volts gyapon, 0 volts. Series gyapon ni nga circuit. Series gyapon ni siya. Even though nani nga element, basta measuring element na gani, di na siya gina consider as parts of circuit, no? So, mara nang wala. So, mahulog lang ni nga circuit nga purely series. Okay? So, akong next nga step untaan is i-combine ning duha, no? IR1, tungkol kay series siya, IR1 is equal to IR2. Series naman eh. Diba? Pero kung lahi na gani ni nga resistor, no? Nagini siya isa ka resistor gidiri, dili na ni mag-work nga equation and lahi na nga method atong kinahanglan. Patungod kay series ra gyapon eh nga circuit because VO is just a measuring, no? Virtual lang ni nga tool. So mara siya wala. So pwede natin siya matampo as IR na lang, no? Or I. So 8 minus I times 1.2K plus 4.7K minus 0.7 equal to 0. Pwede na siya ma-shift solve dito sa calculator. Pilay mo gawas. .24 milliamperes. So current is 1.24 milliamperes. I think wala man ang kinahanglan, no? For the voltage of each resistor, pwede na i-solve individually. So voltage ni R1 is equal to V cos I times R, 1.24 M milli times 1.2 kilo. Uh, 1.488. Voltage ni R2 is 1.24 VIR times R, 4.7K. Milli day dapat ni. So VR2 is equal to 5.83. Total na ba siya 8? 5.83 plus 1.44, 49 plus 0.7. Total na siya 8 volts. Okay? So, kaninga exercise or kaninga example is to introduce this notation. Basta na ganing ani. Ang iyang kana nga terminal, no, kana nga polarity nga terminal is connected dire, just like this one, and the other terminal is connected directly to ground, the same sa atong measuring equipment, measuring tool. Dapat nato na solve si VO, no? How much is VO? Then pila ang na-solve ni, pila nga voltage drop ang makita ni VO in this case. If this is 0.7, voltage sa R2 is 5.83. So 5.83 plus 0.7 6.53. Okay, kung man di ba? 5.83 volts man ni siya. Kung ato ganina. 5.83. Plus 0.7 volts. Meaning, ang kakita nga voltage ni VO is equal to 6.53 volts. Final answer.
Excuse me, sir.
Ah,
Pero mabalik tong yun sa ko ang 6.53 na nawala magud sa ako.
okay. Kuan. Ang total current sa circuit is 1.24, right? Kani kay series naman ni siya. So meaning, nakuha po nato ang voltage ni resistor 4.7K by multiplying 1.24 milli and its resistance nga 4.7 to obtain 5.83. So 5.83 ang voltage that delay. So gi-add lang nato, 5.83 plus 0.7, 6.53. Okay, Raman?
Okay, sir. Thank you, sir.
Okay. Sige. Any more questions? Clarifications? So maybe most sa atong na-discuss karon, even though new to you, kay understandable lang because simple pa series circuits pa man sad to and simple circuits pa man sad. And para pwede rin ninyo ni-review, post gapon ako ang link ani sa e-learn, upload na ako sa YouTube, then ma-review ninyo in a later nga date, a later nga time. Mag-post siguro gapon ko og activity para inyong praktisan. Series circuits la. So, next meeting na ang parallel. Okay? Any other questions, clarifications? Wala na? Kuan? Series diode circuits or series diode. Another sa book ay series diode configuration. So, pwede naman series diode circuits.